All right. So nuclear energy. So you have learned the other types of energy before this, which are kinetic energy, potential energy, which consists of two types of energy, which are gravitational potential energy and elastic potential energy. And you have also learned about kinetic energy, heat energy, electrical energy, and so on. So for today's lesson, we will be learning about nuclear energy, and the symbol for the energy is the same. It is capital E. Okay, capital E, but the formula will be different lah. So in this page 208, so in the picture it shows the sun. Okay, the sun provides light and heat energy to Earth since millions of years ago. Hydrogen nuclear fusion occurs in the core of the sun under very high pressure. In this nuclear reaction, two hydrogen nuclei fuse to form a helium nucleus and release nuclear energy. Okay, so again, we refer back. This one is involving two hydrogen nuclei, and it will fuse to form a helium nucleus. So by referring back to the periodic table, mana sudah tu periodic table tu? Okay, based on this periodic table, we can see that the hydrogen here is atom number 1. Atom number 1, and the helium is atom number 2. Okay, atom number 2. Now, how do we get the helium nucleus? By fusing two hydrogen atom. It is by fusing two hydrogen atoms, H11, U plus with another hydrogen nucleus, hydrogen 11, so it will produce helium. Okay, it will produce a helium nucleus. Sorry. Okay, we produce helium nucleus. Now this fusion will need a very high temperature and also a very high pressure for it to be able to occur. Now the sun provides that very suitable condition for this type of fusion to occur, because the core is have very high temperature and also high pressure. Okay, so this energy is radiated to the surface of the sun in the form of light and heat energy, as shown in this photograph. Okay, so nuclear energy, this is the definition for nuclear energy. It is known as atomic energy. Atomic energy released during nuclear reaction, such as radioactive decay, nuclear fission, and nuclear fusion. You have learned about radioactive decay in our previous subtopic. Now we will be learning about nuclear fission and nuclear fusion. Right? So we will be comparing nuclear fission and nuclear fusion. Okay, nuclear fission and nuclear fusion are two nuclear reactions that produce nuclear energy. There is a loss of mass, or we call it as mass defect. Okay, there is a loss of mass, or mass defect occurs during this nuclear reaction. So in this figure below, it will show a nuclear fission, and the other figure will show a nuclear fusion. Okay, nuclear fission. It is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. Okay, so this is a splitting of a heavier nucleus into two or more lighter nuclei. And in that process, it will release a large amount of energy. So it will start with a heavy nucleus. So for example, here it uses uranium. Okay, this is a very heavy nucleus. Okay, uranium 235, 92. Okay, so in order for us to be able to split the uranium nucleus into two or more lighter nuclei, we will be using one neutron. Okay, so it will be bombarded with a neutron. Now, why do we use neutron and not proton and electron? Anyone can guess why we use neutron to bombard the uranium nucleus and not electron or proton? Apa sebabnya? You recall back what is contained in the nucleus, and you relate why we use neutron as the to bombard it and not proton or electron. Anyone can answer? Ya, memang neutron no charge. Yes, it is neutral, no charge. What is contained in the nucleus? What is contained in the nucleus of the element? Yes. In the nucleus, it has proton and also neutron, kan? Ini nanti, the blue one is the proton and the red one is the neutron. Okay, so if we use a proton, to bombard the nucleus of the uranium, what will happen? Proton and proton. Apa akan jadi if you use proton to bombard the uranium? Just remember that if same charge, what will happen? If you use the same charge, then the tendency for it to be repelled is very, very high. Kan? Kalau kita gunakan proton to bombard the uranium punya nucleus, which consists of proton and neutron. So when the same charges, you try to bombard it, it is quite hard because the same charges will try to repel each other. But if you use an electron, what will happen? What will happen if you, if you use an electron to bombard the nucleus, the tendency for the electron to be absorbed and stuck to the nucleus is very high. So it will be more attracted to the nucleus because of the opposite charges. So that's why we are using neutron, which doesn't have any charge, to bombard the nucleus for it to be able to split the nucleus into two or more lighter nuclei. Okay, so that is the reason. Now please take note on the number, the the atom number, and also the nucleon number for each of the element that we use, because this one will be used in the calculation. So when the uranium nucleus is split, so it will create another uranium nucleus, but this one is uranium 236. Okay, uranium 236. This is a radioisotope of uranium, and it is still unstable. So what will happen is it will continue to split. So this time it will split into two. It will split into two new elements, which are krypton 92, and also barium 141, and also another 3 neutron will also be released. So in the process of splitting into two lighter nuclei, so it will create a large explosion, which result of the nuclear energy. So when you add all of the numbers again, so this is the process. Let's check if the numbers are balanced on the left hand side and on the right hand side. So on the right hand side, sorry, on the left hand side, this total here 235 you plus with 1, so total will be 236. Okay, so it is the same as this one after the arrow. And also we check again on the right hand side after the arrow, 141 you plus with 92, and then you plus again with 3 because you times 3 times 1, so it will be equals to 3. So when you add all the numbers together, it should be also equals to 236. Okay, so all the numbers must be equal. It has to tally. Dia mesti tally. So yang di bawah tu, check if the numbers, the total are the same. So 92 plus 0, this one is 92, 92. And this one, 56, you plus with 36, you plus with 0. Now be very careful about this part here, because usually students will make mistake when they multiply this number, 3 times 0, they will see it as 3. Okay, so be very careful. 3 times 0 is 0 and not 3. So it should be equals to 92 also on this part. And please don't forget also, at the end of the equation, you have to write energy. Okay, you have to write energy because the energy is the product of this process, this nuclear fission. This one we will later calculate by using the formula of E equals to mc squared. Okay, so we will discuss on that one later on. All right, so any question about this nuclear fission equation? You understand how to do the equation, the calculation? Okay, can I continue? Okay. Okay, next one is nuclear fusion. Fusion means you combine. Nuclear fission is a nuclear reaction in which small and light nuclei fuse to form a heavier nucleus while releasing a large amount of energy. Now, previously, fission, it splits a heavy nucleus into two or more lighter nuclei. So fusion, it combines. Okay, it combines a small and lighter nuclei to fuse to form a heavier nucleus. This nuclear reaction happens under extremely high temperature and pressure. So remember, the condition for this to happen is it has to be in an extremely high temperature and pressure. For example, at the sun. So example of this nuclear fusion is by using deuterium and tritium. Deuterium is the isotope of the hydrogen. Because we have three types of hydrogen atom, H11, this is the basic one. We have deuterium, H21, deuterium because it consists of two apa? Consists of one neutron, extra neutron. And the other one is tritium, 3,1. Okay, so these are all isotopes of hydrogen. So when we fuse deuterium and tritium together, like in this figure here, deuterium you fuse with tritium, so it will produce this part here. 2 plus 3 is 5. Below is 2, 5 and 2. So it will create helium and a neutron and also energy. So this part here also should be equal. 4 plus 1 is 5. And below is 2 plus 0 is 2. So it should be equal. Okay, the numbers should be equal. Okay. All right, so let's try and do the other question. A relationship between energy released during nuclear reaction and mass defect. So energy is E, mass defect. The word mass, so we will be using M. Okay. E and M. Atomic mass unit, or in short AMU, is a measurement of the mass of an atom. The mass of an atom is too small and difficult to measure using units such as grams or kilograms. Therefore, a relative comparison between the mass of an atom with the mass of one carbon-12 atom is used. Isotope carbon-12 is used as a reference because carbon can be found in many compounds found on Earth. Okay, so that is why we use the isotope of the carbon-12 in the calculation. Okay. Now you have learned some of this in chemistry. So ada di sini nih Avogadro number. So what is the value? The Avogadro number. Berapa dia punya nilai? Anyone can tell me? Because you have learned this in chemistry also. Avogadro number. 6.02 times 10 to the power of 23. Okay. The mass of one carbon-12 atom is 12 AMU. And 1 AMU is defined as a mass equal to 112. 112 that of the mass of the carbon-12 atom. Now, one mass of 1 mole of carbon-12 is how much? Siapa? Hold on. Ini. Okay. This is how the value of the 1 AMU is calculated. So the mass of one carbon-12 atom is this figure here. 1.99265 times 10 to the power negative 26 kilogram. So that's the value. Okay. 1.99265 times 10 to the power of negative 26 kilogram, which is very, very light. So the mass of one carbon-12 atom is 1.66 times 10 to the power negative 27 kilogram. Ini 1/12. Okay, yang penting di sini is this value, 1 AMU. That's the most important value, but you don't have to memorize this value because that value is given in the list of formula. Okay, that one will be given in the list of formula. So when converting the mass into kilogram to be substituted into the equation, the units must be in kilogram. We have to use SI unit. So convert AMU into kilogram. So you have to times with this number, 1.66 times 10 to the power of negative 27. Okay. Let's look at the example of this equation. In a nuclear reaction or radioactive decay, the total mass of the decay product is always less than the total mass of the radioactive nucleus. Yes, it is always less. Always less. Okay. This loss of mass is known as mass defect. And we will be using symbol M to represent mass. Now the figure shows an example of a change in total before decay mass. Total before decay mass and after a nuclear fission. So we start with a uranium atom, uranium 235. So the specific value of the mass of the uranium is this one, 235.04392 AMU. Okay, but the number is rounded off to a round number so that it is easier to identify. So in the calculation, you will be using all of this number. So make sure when you punch in the numbers into your calculator, it has to be precise. Otherwise, you won't get the exact answer. Okay, so this one, you use 1 neutron to bombard the nucleus of the uranium. And the neutron is 1.00867 AMU. So when you total up both of this before the reaction happens, total mass before fission, you add both of the numbers together, then this is the total. Right? So when the nucleus has split into 2, so it will create another 2 new elements with 3 neutrons also. Okay, so all of that numbers you have to add to get the total mass after fission. Okay, semua kena tambah lah. This one tambah, this one tambah, and this one also you add. So it should be equal to this one. Now compare the value before and after the fission. This one is before the fission. This one is after the fission. So if you compare both of these numbers, both of the numbers, you will see that it is not equal. There is a slight there is a slight difference. So that difference is what we call as the mass defect. Dalam BM, mass defect is known as cacat jisim. Okay, cacat jisim, mass defect. So this is the value of the mass defect by subtracting the value after the fission from before the fission. And this value of the mass defect we will be using to calculate the nuclear energy produced in it. Okay, by using the formula of Einstein, E equals to mc squared. Okay, so next step is for you to convert the mass defect in AMU into kilogram, because we should use SI unit in the calculation. So the formula, this is the formula that I've mentioned just now. E equals to mc squared. E is the total energy release, M is the mass defect, and C is the speed of light in vacuum. Now, speed of light in vacuum is also given in the lesser formula, and the value is the value of the speed of light is 3 times 10 to the power of 8 meter per second. Okay, so that's the value. Okay, and then you convert we try to use this one as the example. Okay. The equation shows a radium 226 decaying into radon 222 by emitting alpha particle. So by emitting alpha particle means it will include the helium nucleus in the equation. Okay, this is the alpha particle. So you are given the mass. Okay, this is the mass of the radium. This is the mass for radon. And this is for helium. Calculate the nuclear energy release. So actually in the equation, there should also be energy in the equation. Okay. So first thing that you have to do is to find the mass defect. Find the mass defect before the reaction and after the reaction. Okay. Better I use this one. Kejap ah. Inilah. Try and do this one dulu. Example-nya. Same like now lah. The ones in your textbook. Okay, we try to calculate first. So first thing is to find the mass defect in AMU. Try to find this one dulu. Okay. So A, to find it in AMU. So we start with this one, radium. So you take this value, 226.02536, and then you minus with all of this number after the arrow. You minus for radon 222.01753 plus with 4.00260. Okay, then you will get, coba kira berapa? Help me to calculate how much will you get? Sudah kira? Okay. Ya, Terry. 0.00523 AMU. Okay, don't forget to put the unit dulu. AMU. Okay, next one is in kilogram. So you convert the AMU into kilogram. So 0.00523 you times with this number. 1 AMU is equals to 1.66 times 10 to the power negative 27 kilogram. So you multiply with that number. 1.66 times 10 to the power negative 27 kilogram. So you should get berapa? 8.6818 times 10 to the power negative 30 kilogram. Okay, semua dapat itu kan? Okay, next one is calculating the amount of energy released in joule. Calculating the amount of energy released in joule. So you use this one, E equals to mc square. M is 8.6818 times 10 to the power negative 30. Now C is the speed of light, 3 times 10 to the power of 8. But don't forget to put square. Jangan lupa, kasi letak itu square. Now, what is the total? Berapa total dia kamu dapat? 7 point. Unit? Okay, yes, in joule. Unit is in joule. If you don't want to write the answers with long numbers, so minimum is 2 decimal point, 7.81. Itu yang minimum dia lah. Okay, so this number is okay. 7.81362. Okay, next one is how to write the value into electron volt. So you are given here 1 electron volt is equals to 1.66 times 10 to the power negative 19 joule. So convert the joule into electron volt. Jadi berapa? The second part of the question. Convert it into electron volt. Should you divide the number or should you multiply? Okay. Mm. 1 electron volt is 1.66 times 10 to the power negative 19 joule. Okay, 7.81362 times 10 to the power of negative 13 joule. So bahagi kan? So it should be, you divide, so you will get 470700. Ngam kan? Okay, check the answer. Yeah. Okay. Ini ngam. This one also ngam. This one ngam. This one also ngam. Okay. So that is the step on how to get the value for E equals to mc square by using the steps just now lah. First, you have to find the mass defect in AMU, and then you convert it into kilogram, and then you can use that value in kilogram to substitute it into the equation to find the value of the nuclear energy. Okay, the answer is in joule. Let's see here. Yeah. Okay, it is in joule. So far in this one, dia tidak minta dalam electron volt, just like the one that we have discussed just now. Okay, that one, example number 1 is for fission. Example number 2 involves fusion. Same thing lah, sama saja. Tambah tolak saja. Find the mass defect first. Okay, you find the mass defect. This part, because they're plus, so you have to plus 2.014. You plus with 3.016. Then you minus with all of this after the arrow. Minus with 4.003 and also this one 1.009. Okay, so dapat 0.018 AMU, and then convert the value of AMU into kilogram. Then you will get 2.988 times 10 to the power negative 29 kilogram. Then substitute it into the equation of E equals to mc square, and you will get the answer in joule. Okay, so itu untuk example 2. Any other question for this calculation? Senang? Boleh? Boleh paham? Should be no problem lah kan? Yang this calculation, it's not that hard because the values are all given. So it just you have to do the calculation carefully because it involves a lot of long numbers. Right? Yang ini nanti kita akan discuss lagi in our next class. Ada tinggal sedikit saja nih. Only a few, so we will discuss that in our next class. So if you have no more question, then you check your workbook. In your workbook, Okay, dia tidak tunjuk tu yang apa lah, half-life. Got half-life and also this one. Okay, so we'll be discussing that again in our next class. No more question? All right, so if we have no more question, then you can go. Can be excused right now. Thank you all.
Thank you, teacher.